Now, it is now my pleasure to introduce our keynote speaker, Professor Francesco Ayala of the Department of Ecology and Evolution of the University of California, Irvine, and the Donald Bren Professor of Biological Sciences. He was appointed in 2003 as University Professor, the highest title at the University of California, and is the only professor currently holding that title at UC Irvine. Francesco Ayala has addressed many issues of this conference from multiple perspectives. He's published more than 980 articles and is the author or editor of 34 books. His books on the scientific side include Systematics and the Origin of Species, 2005, Handbook of Evolution, Variation and Evolution in Plants and Microorganisms, Modern Genetics, Population and Evolutionary Genetics, a primer, Evolving the Theory and Processes of Organic Evolution, Evolution, Molecular Evolution, going way back to 1976. For this major scientific work, in 2002, he was awarded the 2001 National Medal of Science at the White House, putting him in the distinguished company of such people as James D. Watson, Francis Collins, Hans Bethe, Richard Feynman, David Baltimore, Sewell Wright, Barbara McClintock, and other great names in the world of contemporary science. He's been a member of the U.S. President's Commission of Advisors on Science and Technology, President and Chairman of the Board of the American Association for the Advancement of Science, and President of Sigma Xi. On the philosophical and theological side, which is particularly the surprising dimension of his training, he is the editor of Studies in the Philosophy of Biology, and most recently the author of 3 books. One of them depicted here, Darwin's Gift to Science and Religion, 2007, Human Evolution, 2007, and Darwin and Intelligent Design, 2006. In this recent book depicted here, a book I highly recommend truly to people in this audience, he addresses head-on the issue of evolution and natural evil, the topic that since Hume has seemed to so many to be the checkmate of all theistic interpretations of nature, and argues for the great freeing that Darwin provided theology from some constraining notions of design and providence in nature. Today's talk, entitled Darwin's Revolution from Natural Theology to Natural Selection, will surely continue some of these lines of discussion. I should also note that Francesco Ayala forms the link between today's conference and the first Notre Dame Conference on Evolution of 25 years ago, organized by Father Ernan McMullen. As one president at that conference myself, it's my particular pleasure to welcome him again to this podium and to address this distinguished audience on evolutionary science and these interface. So with these points, please join me in welcoming Francesco Ayala with our keynote address. And by the way, at the end of this, we'll take, if time permits, we'll take some brief questions. And I ask you to use the microphones because this is being recorded. So if you have a question, I will moderate that. But anyway, join Francesco Ayala.
Thank you very much, Phil, for the gracious introduction, and thank you, Professor McHenry and Professor Sloan, for inviting me to participate in this conference. I think I have a microphone. Can you hear me? Yeah, I will be offered another microphone, but I think this probably will suffice. As Professor Sloan mentioned, I was here 25 years ago for a conference that had somewhat similar title. I am not sure I remember it. Science, Evolution and Creation, I think it was, that came out eventually as a book, which has gotten a lot of, long legs in the issues that concern us today and have concerned many of us for a long time, the relationship between science and religion, and particularly evolution and religion. In April 28, 1937, early in the Spanish Civil War, Nazi airplanes under the command of General Franco bombed the city of Guernica, the spiritual home of the Basques, a small civilian city. It was no military target, but the city was completely destroyed, and 25% of the inhabitants, men, women, and children, died. The greatest painter, Pablo Picasso, had been commissioned by the government, by the Republican government in Madrid, to paint a mural for the world exhibit that was going to take place in October of that year in Paris. Picasso, having heard of the bombing, in a fury of manic energy, just in 12 days, outlined this painting, which is a huge painting. It's about 25 feet by nearly 8 feet. It's called Guernica, like the city of Guernica that was bombed. Well, we will all agree that this painting was painted for some purpose, to convey some message, the inhumanity of man to man and the brutality of war. In the same way that we would agree that the clock up there has been designed to tell time, or a car has been designed for transportation. And if they existed because of these functions, of these purposes that they serve. You can see here the letters of the alphabet and the digits. These are butterfly wings. Now, we could use these letters to write English text, and we could use the numbers to do arithmetic calculations, but I do believe that all of us would agree that's not the purpose for which they have been designed, these letters and these numbers. In the same way that we can use a mountain for skiing or a river for navigation, but that's not the reason why the mountain and the river exist. What about the human eye? The message that I want to convey today is that the human eye shares something in common with the Guernica and the car and the clock, and something in common with the butterfly wings and the mountain and the river. It has in common with the Guernica that if it were not for the purpose it serves, it would not have come to exist. The eye has been designed for the purpose of seeing. It shares in common with the butterfly wings and the mountain and the river that it has not been designed as the result of the intentional actions of a designer, but it is the result of a natural process. And we owe this discrimination in interpreting the eye with sharing something in common with the two groups of objects or entities that I have pointed out to Darwin. It was Darwin's greatest discovery that he brought the design of organisms, the purposeful aspects of the living world, to the realm of science. They had been left out by the Copernican revolution. And that makes of Darwin, doubtless, one of the greatest scientists of all times. After all, organisms are the most diversified, the most complex, the most interesting entities in the world, and that they could be explained by science. We owe it to Darwin's discovery and natural selection and his other elaborations. There is a narrative of the history of ideas that says that there were two great revolutions in science that changed forever the image that we humans had of ourselves and our place in the universe. One is the Copernican revolution with the publication by Nicolae Copernicus on 1543, the year of his death, of this book on the revolutions of the celestial spheres. This is a drawing from a contemporary German book, contemporary of the publication of Copernicus' book, where we have the Earth in the center with the moon, and then we have the other spheres, Mercury, Venus, then the sun going around the Earth, Mars, Jupiter, Saturn, and eventually the 12 star constellations. This is a similar drawing by Copernicus, by his own hand. Now the sun in the middle, Mercury, Venus, the Earth with the moon, Mars, Jupiter, Saturn, and the stars. By the way, both of these books were written in Latin, like books for the next 2 centuries, scientific books could be written in Latin. Well, similarly, as the Copernican revolution had removed the Earth from being the center of the universe to become just one more planet revolving around the sun, it is said in this narrative of the history of ideas that Darwin's accomplishment, or Darwin's revolution, is that he removed humans from being the center of the world of life, with all life created around humans, and made us just one more species, represented in the argument developed in The Origin of a Species by means of natural selection, and many of his other books, published 150 years ago, 1859, and our relationship with other organisms shown in this model representation. We are closely related to the chimpanzees with a relatively recent common ancestor, and then more remote ancestors with all the apes and the monkeys and mammals in general and vertebrates and other animals, and ultimately with all of life. This narrative of the history of ideas is very unsatisfactory because it tells something that is true, but it misses what is most important about these 2 scientific revolutions. And it is the jointly represented true and the fundamental aspects of the scientific revolution, which is bringing the realities of the world of nature in the realm of science, explanation by natural laws, a commitment to the notion that the world of nature consists of matter in motion, governed by laws that can be discovered, that tend to be simple, that can be tested by observation and experiment, and that have universal validity within their own realm. So one has to see the Copernican revolution in connection with some of his followers, of which I have highlighted 2 who lived about 100 years apart from each other, and Galileo nearly 100 years apart of Copernicus. Here is Galileo, Newton, and is the discovery of laws like force equal mass times acceleration, or the inverse law of attraction, that the force of attraction between 2 bodies is proportional to the product of their masses, but inversely related to the square of their distance. Laws that apply on Earth as well as in the heavens, laws that could be tested by observation and experiment. Well, the Copernican revolution had left out living organisms and had left them out because of an argument that had been going on actually since the times of classic Greece and through certainly the Christian tradition, namely what was argued and developed with more detail than by anybody else by William Paley in his book Natural Theology, namely that organisms give clear signs of having been designed, and as William Paley would say, wherever there is design, there is a designer. William Paley was an Anglican clergyman, author of several books of theology, but known in his day more by his public speaking even than by his books. He was spending much of his life arguing against slavery, was a well-known abolitionist. In 1800, he became ill, and he had to give up his public speaking career and decided to study the advances of biology that have taken place in the previous decades. And out of that study came this book, Natural Theology, that Darwin studied when he was a student at Cambridge. He was part of the canon. William Paley argues again and again that when we see a limb or an organ or a whole organism or group of organisms that consist of many parts that are all integrated in such a way that the entity cannot function, say the organ cannot function, unless all the parts are put together in a precise way, that is evidence of design. And again, where is the sign? There is a designer. He starts the book, which is beautifully written, by the way, and marvelous knowledge of the biology of his time, going beyond what one could have expected from a non-professional biologist. He says at the beginning, assume that I'm walking with a friend and I accidentally kick a stone. And my friend says, oh, where does the stone come from? I will respond, for all what I know, it may have been there forever. There is nothing to explain. But assume that we go a few steps farther and I kick a watch and he asks me the same question. Certainly I cannot give the same answer. A watch is made up of many parts, clearly integrated and precisely integrated to tell time. So I have to say somewhere there is a watchmaker. And then extends the argument, of course, in proceeding with great detail to all sorts of animals, plants, the relationships between the genders, between predator and prey, between organisms and their environment, and again came to the same conclusion. A designer is the author of these relationships, and the only designer that can account for so much complexity and diversity in the world is God. Well, it was Darwin's greatest contribution to science and to the history of the ideas and to the history of humankind that he was able to show that design could be explained also as the result of natural processes. That is, the design that we find in nature, in organisms, and in the relationships between organisms. Now, The Origin of a Species is commonly said to be a book about evolution. It is not a book about evolution. It's a book about natural selection. And Darwin considered that a summary that he had written in a hurry, in just a little less than a year, a summary of a multi-volume book that he was planning to write on natural selection, which is why he don't call this book Natural Selection, but just The Origin of a Species by means of natural selection. He has 14 chapters. In the first chapter, Darwin examines the experience of farmers and animal breeders who take advantage of hereditary variations that occur in plants and animals to produce the crops and the animals that we use for food and for other purposes as well in human life. And then, starting with chapter 2, he describes natural selection, tries to extend that idea that hereditary variations exist in organisms to from the practice of farmers and animal breeders to the whole of life. And he develops the concept, considers objections, starts to argue from many different perspectives. And then at the beginning of chapter 9, he says, as it were, well, if my theory of natural selection is correct, evolution must have happened, and must have happened in this way. He uses evolution only as evidence for natural selection. And then he has 2 chapters dedicated to geology, 2 chapters to biogeography, 1 to comparative anatomy and comparative embryology, and in the last chapter comes back to natural selection. It is well known that Darwin went between late December 1831 and late October 1836 for nearly 5 years in a trip around the world, where Darwin saw lots of evidence for evolution. But evolution was accepted by many biologists at the time. 50 years before the origin of a species, in the same year in which Darwin was born, in 1809, Lamarck had published a book about evolution, philosophical zoology, in literal translation. And many other biologists accepted evolution, but like Lamarck, they thought of evolution as a process that was going gradually improving organisms in some directions. And Darwin says, no, that's not how evolution has to occur. If my theory of natural selection is correct, we will see that some parts of organisms change at one point, others at another point. Some may not change if the environment doesn't change. There is no need for changing the organisms. And he uses examples like one that we will see very briefly, Nautilus, a snail, as organisms that have not changed for millions of years because they live in environments that have not changed for millions of years. So when he returned from the trip, and he starts a series of notebooks, kind of diaries, which he recorded, actually, every idea, every thought that he had, every experience he had. Now these notebooks have been published, and we know that somewhere towards the very end of 1837, this little more than a year after he had returned from the trip, and sometime in 1838, he comes upon the idea of natural selection. And he was looking for an explanation of evolution. He had written earlier in the same notebooks, what is the point of keep looking for more and more and more evidence of evolution if we don't know how to explain evolution and how it happens and how organs and limbs and everything else comes to be. In other words, he was in many ways, so to put it, he was trying to answer William Paley's problem, how to explain the sign without the signer. He comes upon the idea, as I said, towards the end of 1837, the beginning of 1838, and he says, now I have a theory to work with. And thereafter, all his life, he refers to natural selection as my theory. He never says of evolution as my theory. No, his theory is the theory of natural selection. Here is one of the places where in a few words, in a few sentences, he summarizes how natural selection works. This is from chapter 3. He says, as more individuals are produced that can possibly survive, can be thought improbable, seeing that variations useful to man have undoubtedly occurred. He's referring here to the chapter first, where he has discussed the experience of farmers and animal breeders. Can be thought improbable that other variations useful in some way to each being should sometimes occur in the course of thousands of generations. If such do occur, can we doubt that individuals having any advantage, however slight, over others would have the best chance of surviving and of procreating their kind? On the other hand, we may feel sure that any variation in the least degree injurious would be rigidly destroyed. This preservation of favorable variations and rejection of injurious variations I call natural selection. A very simple concept that, as it was mentioned by Professor Sloan and is well known to everybody. Now we have a whole body of mathematical theory, of genetics, of ecology, and all sorts of knowledge around this simple concept. But this is the simple concept, the one who made possible all this development, all this understanding of how to explain adaptation. I'm seeing all of you very serious. I'm very concentrated, and I think we have to, I want to change our mood a little bit, and I will start by pointing out that Darwin didn't write this text with a Spanish accent. I do that for color. Well, the reason why I want to lighten the environment only for a moment is the next slide, which looks very frightening, but it is not. Okay, so here is how natural selection works. This is based in an experiment that I was doing, that we were doing when I was a student at Columbia University in 1961, what is now called molecular biology. Don't exist, not by that name anyway. And we were doing experiments trying to understand how natural selection would work under certain circumstances. And also, we were using these experiments actually to measure mutation rates, how the rate of incidence of variations that would be useful to the organisms. So in this experiment is done with E. coli. This is the colon bacterium. We have trillions of E. coli in our digestive tract. So if something would go wrong with the experiment, there was no reason for major concern about getting sick. And bacteria can synthesize all their organic compounds. All what they need is a source of energy. So the way they are cultivated is you have a water solution of sugar. So you have sugar that they will use, usually sucrose or glucose, something else. They can synthesize, for example, the 20 amino acids that make protein. We can synthesize only about half of them, which is why we have to eat protein. We have to eat the other half of the amino acids because we cannot make them up by ourselves. But bacteria do. However, in this particular strain, which was not able to synthesize one of the 20 amino acids, histidine. In addition, these bacteria are sensitive to the antibiotic streptomycin. Bacteria that had not been exposed to an antibiotic are sensitive to the antibiotic. They will be killed if they are exposed to the antibiotic. So now we have this culture with some histidine, the amino acid being provided with the sugar source of energy, and we introduce a few bacteria, and in a couple of days or less, you have 20 billion bacteria. The next step in the experiment is to put a drop of streptomycin, and the bacteria die. All die. Well, not all, because by spontaneous mutation, whether there is streptomycin or not in the environment, mutations from sensitivity to resistance to streptomycin occur with a frequency of about 1 in 100 million. So you expect among the 20 billion to have about 200 that would survive. And 2 days later, you have 20 billion bacteria, all resistant to streptomycin. Now, the bacteria are moved to an environment where there is no histidine, and they cannot divide, they die, except that, again, mutations happen spontaneously from not being able to being able of synthesizing histidine with a frequency of about 4 in 100 million. So 800 will survive, and in a couple of days, you have 20 billion bacteria, all with the two attributes, resistant to streptomycin and able to synthesize histidine. Why they have these attributes? Because those are the demands of the environment. That's what the bacteria need in order to survive and multiply in that environment. Notice that the probability of those two mutations is 4 divided by 1 followed by 16 zeros. Even with a huge culture of bacteria, you would not have one bacteria with those two mutations, not to speak of all the 20 billion of them having those two attributes. So I will call your attention, not that in this community, particularly in this audience, needs to be pointed out because most of you or all of you will know that here you have something which is very improbable if you don't consider natural selection. Some of the arguments that are being made against evolution, a natural process explaining adaptation, is that these mutations are so improbable. Well, combined with natural selection, they become the common outcome very quickly. Very briefly, one example from natural selection in nature, one example of natural selection in nature. This is very well known. It's an example that appears in textbooks of biology. That has to do with a particular moth, which is very common in the wet forests of North Wales and England, which is called the peppered moth. The scientific term is Biston betularia. And it's called the peppered moth because it has this characteristic appearance of salt and pepper, as you all can see. It is there. There's the peppered moth. I was trying to make you to see your faces expressing surprise at my saying that this is the peppered moth. Well, it is there. This is a mutant, the so-called melanic form. These are sitting on the bark of a tree in a humid forest. They tend to be called by lichens. And when a tree is covered by lichens, the peppered moth has a very cryptic phenotype. It's difficult to see. The main predators of these moths are birds. So these mutants, whenever they happen, are obviously the first ones the bird will see. Birds will see the world very much as we do, and they are the first ones that get eaten. So in collections that exist, British people being great collectors of moths, butterflies, and birds and the like, collections that exist previous to 1850, there is never a melanic form, a black moth. But in 1850 appears the first one, and then they start to appear in frequency, in greater and greater frequency through the following decades until about the 1960s. So what had happened? The Industrial Revolution. The use of coal in factories, and the trees get covered by soot, the lichens have died, and now this is the appearance of the bark of a typical tree in the same area, and now the one which is protected by coloration, by the phenotype, is the melanic form, and the other one is very visible. So this is the one that the birds are going to eat more often, and so the melanic ones start to increase in frequency. It's a little bit like with the bacteria. If you create a new environment, if you change the environment, the natural selection takes a different configuration. Then after the severe laws, anti-pollution laws, anti-contamination laws were passed in Great Britain in the middle 1960s, the lichens started to grow again on trees, and the frequency of the black moth started to decrease again. Typical evolutionary process. The best place, one of the best places to study evolution in action are groups of islands, archipelagos, which are very isolated from continents. Most evolution takes place in continents because they are large masses. Colonization of archipelagos, which are remote, happens only rarely and only by a limited number of organisms. No group of islands is more isolated from any continent than the Hawaiian Islands, about 2,000 miles from Southern California, where I live. All the Hawaiian Islands are formed where the Kilauea volcano is now active. I have been in Hawaii a number of times with very good excuses, like going to collect Drosophila flies to study speciation. I have visited the Kilauea volcano when it was not active. Now for the last 15 or 20 years, it has been active. There is a hole on the surface of the Earth through which volcanic eruption takes place at this position. So eruptions take place, the material accumulates, and if it accumulates long enough, then the material crosses the surface of the water, of the ocean, and you have an island. Something else is going on, and it is that the Hawaiian Islands are sitting on the North Pacific tectonic plate, which is moving northwesterly at a rate of 2 inches per year. So the islands are formed here, and they are moving 2 inches per year that way. When there is no volcanic eruption for some time, then the new eruption creates a new island, or a new volcano, a new mountain within the same island. The big island of Hawaii, for example, has the Hokala Mountains, which are 800,000 years old, already very heavily eroded. Then the two highest mountains, Mauna Kea and Mauna Loa, and now Kilauea, where the activity is taking place. So that Kauai, the largest island towards the northwest that still exists, was formed about 4 million years ago. The other ones sometime in between. But actually the Hawaiian Islands were formed here starting more like 20 million years ago. And the Midway Atoll, which was very important in Second World War, is up there. It was formed about 20 million years ago, but now has been completely eroded and is, as I said, just an atoll. So these land masses, which are relatively small, have been colonized by organisms, but by very few kinds over time. And here you have the main groups of organisms that are found in Hawaii, that is before other organisms were introduced by humans in modern times. First, Drosophila. These are the little fruit flies that we use, geneticists use for experiments in the laboratory because they reproduce very fast, inexpensively. They're very easy to keep. There are about 2,000 species in the world. 500 of them are in Hawaii, 25%. Now, the total area of the archipelago of Hawaii could not be more than 20 or 30%, say, the area of the state of Indiana. And yet, you have 25% of all the species in this small area. Why? Well, now we know because we have reconstructed with genetic ways the story, some nearly 20 million years ago, where now Hawaii is the big island, there was what now is Midway, was colonized by some fruit fly, which came, according to our best reconstructions, from what is today the state of Oregon. And these flies reached there, and as time went by and new islands were formed, they have the opportunity to diversify in different islands and to occupy different environments because they don't have closely related insects that will compete with them. So the Hawaiian Drosophila are more diversified with respect to ecology, with respect to feeding habits, mating habits, behavior, and otherwise than the rest of the world together. So they feed on flowers and bacteria, on decaying leaves, and all sorts of things that they don't do anywhere else. Why? Because these environments were available to them. They were not competing insects. Well, there were some insects in Hawaii, 3,750 endemic. Endemic means that exists in a particular place and nowhere else, at least by natural processes. So the Drosophila of Hawaii are all endemic. Most of the insects are. You may think that 3,750 species of insect is not a very small number. It is a very small number because we have more than 700,000 species described of insects. So there's just about half of 1%. And moreover, there are very few kinds. 15% of all those insects are just Drosophila. So you have very few colonizers. They have diversified. They are greatly acquired attributes they don't have anywhere else. It's really a great place to study evolution. You have lots of snails, birds, 71 species, all but one exists there only. Darwin was not able to study the Hawaiian Islands. He was never there. He tried of interest for us Spaniards. The first archipelago that he wanted to visit archipelagos, was the Canary Islands west of Africa. They are Spanish islands, but the governor wouldn't let them come ashore because they put them on quarantine the HMS Beagle, which was the boat, and wanted to keep them there for 2 weeks before they would be allowed to land, so they went on to northwestern Brazil. But then once They have gone around southern South America. Eventually, he visited the Galapagos Islands. The Galapagos Islands are on the equator, about 600 miles from the country called Equator, in Spanish, Ecuador. They are also volcanic islands, and they have a number of features. One of them is these huge land turtles. There are big turtles in the ocean, but not on the land. These tortoises are typical of the Galapagos Islands. Galapagos is the Spanish word for tortoise. So the islands were named by the Spanish sailors after these giant tortoises that weigh as adults 300 or 400 pounds and even more, that are very sluggish, and they have a way of life which is very strange in every relevant respects. Darwin measured the speed at which they walk by standing in one of them. These are big animals, and see how far it will go in 1 hour, less than 1 mile. Well, these animals, you can imagine how vulnerable would be to predators, but there are no predators in the Galapagos Islands, as there were no predators, there were no mammals of any kind in the Hawaiian Islands either that we saw a moment ago. Darwin was fascinated by the fact that Spanish sailors could tell him where a particular tortoise came from just by looking at the tortoise, from which island. And famously, Darwin studied the Darwin's finches, which derive all from one single species. There's only one species of finch in western South America, but diversified, like in the case of Drosophila of Hawaii, to use different kinds of foods, a great diversity in size, the great diversity of the beaks, because depending on what foods and what style of life they had. The Galapagos Islands, the ones that exist now, the oldest one was formed 4.5 million years ago, and then others successively. And here you have the species of finches as they have now, again, reconstructed, and their phylogeny, their evolutionary history, studied in great detail, again, using molecular methods, that's using DNA. Well, what is the alternative explanation to evolution? Intelligent design, as you all know very well. This has become now a theory that has been proposed with the argument that there is design in organisms, so there has to be an intelligent designer. It is not said in most of the writings of certain authors who the designer is, because there must be an intelligent designer with tremendous powers, but we don't know who the designer is. They don't want to mention God, so that the theory of, so-called the theory of intelligent design can be taught in schools. This comes in the aftermath, as you all well know, when the so-called creation science, which some states have passed laws to have it taught in schools, was declared unconstitutional. That is the teaching creation science as science in science classes. So they came with this notion of intelligent design, and I want to make in the final part of my talk 3 points. One of them, that intelligent design critique of evolution is wrong. That is, what they say evolution cannot explain, it does explain. Then that it is not science at all. And third, and this may come as a surprise to you, I think when one looks at the consequences, the implications of the theory of intelligent design, is profoundly anti-religious. So anti-religious that I will try to persuade you, or at least you will hear me convey in my thinking, that intelligent design amounts to blasphemy. So long, of course, as the intelligent design is thought to be God, which is what they are thinking of without saying it explicitly in many cases. Well, Michael Behe is the only bona fide biologist who has written a book by now 2 books, proposing intelligent design. His early book was this Darwin's Black Box. He's not an evolutionist. He's a biochemist, and he thought he had come upon a great idea, that is the idea of intelligent design. How do we detect design when a number of separate interacting components are ordered in such a way as to accomplish a function beyond the individual components? Just what William Paley had said. He says that he has discovered this principle of irreducible complexity that he is in a modest mood says is comparable in significance to the discoveries of Newton, where he says an irreducible complex, that is, a reducible complexity applies, an irreducible complex system cannot be produced directly by slight successive modifications of a precursor system, because any precursor to an irreducible complex system that is missing a part is by definition non-functional. See, there's a big difference between Michael Behe and William Paley, which is Darwin. Darwin had discovered natural selection, but Behe is claiming that natural selection cannot do it, because natural selection works by improving a little bit at a time, like in the bacteria or in the moths or in other multiple examples that are known and can be studied without end. Says unless you have all the parts together, you cannot have the organ, the system functioning. So natural selection cannot do it, incrementing a little bit at a time. It turns out that all the examples that Michael Behe uses have been described in detail incrementally. I'm going to use the eye simply because it's simpler to explain for people who may not be knowledgeable of molecular biology and the like. So here we have the human eye, the camera eye, very similar to the eye of many vertebrates, and clearly, unless you have the cornea and the iris and the lens and everything else, and certainly the retina, it doesn't help to have one of these parts and not the others. That's Behe's argument, as it was Paley's argument. And notice, by the way, that the optic nerve, in our case, in the case of humans, is formed inside the eye, so it has to cross the retina to go to the brain, which means we have a blind spot, which at least those of us who are not as young as some others here, now when we go to the ophthalmologist to take care of our eye, we see very well with the tests they made where we have our blind spot. Well, can you have some parts without the others? We don't need to go to fossils. Mollusks are a group of organisms which is much more diversified than the vertebrates, the animals with backbone. They are also older, and many of them live in environments that have changed very little over time. So we can look at modern mollusks, and we find this creature, a limpet, which is a small mollusk, a conical shell about the size of the fingernail in my thumb. They live in the intertidal, and they feed on the microorganisms, algae and the like, that are brought by the tide. But if they are removed by the tide into the open ocean, they will die. So they need to know when the tide is there. They need to know whether there is light or whether there is no light. If there is no light, the tide is there. They attach themselves to the rock with tremendous strength. These are very common creatures. I can go to any of the intertidal areas in California near Irvine, where I live, in Laguna Beach or Newport Beach, and I see hundreds and hundreds of these limpets. Try to grab them. There is no way to pick them up. They attach themselves to the rock so strongly, even if they were moving, eating, when they feel you, they attach themselves. There's no way to move them. Very important to be able to attach themselves that way so that the tide does not take them to the open ocean. So if there is light, the tide is down, this is the time to eat. And if there is no light, this is the time to become attached, because that means the tide is there. Here you have a very interesting kind of mollusk. It's very interesting for those of us who are from Spain, because this is one of the great delicacies in Spain. It's a mollusk that in Spain is called navaja, because it looks like a pocket knife. Navaja is the word in Spanish for pocket knife, and it's open, it's a slit on one side. It's called a slit shell mollusk in English, and that's where the animal comes from. It does not exist in the waters of the United States. I have found it in also some areas of China, but in northwestern Spain it's very common, and we eat it everywhere. Well, this not only can see light, but also can see the direction of light. Here you have Nautilus, the open ocean snail that Darwin mentions as an example of an organism that has not changed for millions of years. They have a little bit more of an elaborate eye. They can see light, the direction of light, and even motion. But these animals have lived in the same conditions for millions and millions of years, so there seems to be no reason why they would have evolved. Another marine snail here, and finally the octopus and the squid, which had eye as complex as ours. They have a camera eye, like we do, and with very similar parts organized in very simple ways, with one very important difference, and it is because, as you saw, the nerve fibers from the very beginning start to form in the outside of what eventually becomes the retina, rather than inside, as it is in the case of vertebrates. So the optic nerve is formed outside, can go to the brain without having to cross the retina. So octopuses and squids, who need very good vision because they are predators, they swim very fast, they are also predated by other predators, so they need good vision, but they don't have this particular problem that we have of having a blind spot, which I think should lead to the proponents of intelligent design to the conclusion that God, the designer, loves octopuses and squids much more than God loves human beings. Here you have the summary of it. This has been known for a long time. I have picked up this figure actually from the Encyclopedia Britannica from the 2005 edition, but has been there for a long time. This is from an article, a long article in the Encyclopedia Britannica, 30 or 40 pages, the big size, called The Theory of Evolution. I have been the author of that article for several decades, and the Encyclopedia Britannica lets me use those figures so long as I give them credit. So there you have it. You may recall, many of you, that there was this trial in Dover, in central Pennsylvania, where the school board had mandated the teachers of biology to teach intelligent design as an alternative to evolution. Biology teachers didn't want to do it. Eventually, there was a court case where the judge, John Jones, a practicing Christian, an evangelical Christian, appointed by W. Bush, presided and eventually wrote a very long decision where he says what I have just been saying in a different way, that the critique that intelligent designers make of evolution is not correct. He says, as you have read already, the ID movement misrepresents the status of the theory of evolution, causes students to doubt its validity, and presents students with a religious alternative masquerading as a scientific theory. The critique is wrong, but also it has no scientific content. One thing that has been said to Michael Behe repeatedly, pointing out the defects that are so common, that prevail in almost all organs or organisms. And he says, well, how do I know what the intentions of the designer are? How would I know that the designer wanted to make a perfect organ? I don't know. So that critique, he says, is not valid. Well, if we don't know what to anticipate from this so-called theory, we cannot test it, so it's not scientific theory. In fact, there is not any evidence, any research, any hypothesis to test. Nothing that has been published in a scientific journal that could be called a case of intelligent design. Philip Johnson, one of the other great proponents of intelligent design, a retired law professor from the University of California in Berkeley, said a few years ago, in 1998, when told in Berkeley, at a small meeting in Berkeley, that there was no any evidence for intelligent design. He said, well, give us 5 or 10 years, and you'll see scientific breakthroughs biologists had not even dreamed of before ID. Well, 5 years have passed, 10 years have passed, there is nothing. But now my final point, and the one which I think should be the most important for the proponents of intelligent design, if one could persuade them, is that the theory of ID, of intelligent design, is contrary to religion. First, because the ID should stand for imperfect design or incompetent design or inept design, but not for intelligent design. And here I have a few examples that can be explained simply. Take the human jaw. It's not big enough for our teeth. So we have to have the wisdom teeth removed and then go to the orthodontist. For many people have to go to the orthodontist to have the other ones straightened, just because the jaw is not big enough for the teeth. Any human engineer who would have designed the human jaw would be fired the next day. And they are blaming God for that. Well, I don't need to belabor the point that the human birth canal is not big enough for the head to go easily and readily, so that millions of innocent children and women have died through history of mankind because of that defect. We understand very well how these two defects or imperfections came about as the brain started to grow, starting roughly 2 million years ago, when our ancestors started to make tools. And in association with that, we see a gradual increase in brain size, presumably because those who were able to make better tools were able to survive and reproduce better tools for hunting or for cutting meat or whatever, and those who were able to make better tools are more intelligent, typically will have, or at least on the average, somewhat larger brain size, and that led to the increase in brain size by a factor of more than 3, a tremendous rate of evolution of the human brain. Well, for the head of the baby to go through the human birth canal, after the brain is becoming so big, the head had to give in somewhere, and one of the places where it gave in is in the jaw, became smaller. As the jaw became smaller, by the way, the teeth have become smaller too. But the selective pressure is on the brain, or was presumably on the brain becoming bigger, so it's only secondarily on the jaw and tertiary on the teeth. So you have these misadjustments that have to do with the human jaw and the human birth canal. The forelimbs is an example that I like to use often, because if you look at our forelimb, at our arm, it's made of the same bones, arranged in the same way as the bones of the leg of a dog, or the wing of a bird, or the forelimb of a whale. Now, what an engineer would design ships and planes and cars made of the same components organized in the same way. They're the same bones. They have been modified slightly as a result of adaptation to the different functions, but they are the same bones organized in the same way in organisms as diverse as the ones I have mentioned, and used for so many different functions. Why? Because they inherited this organization and these structures from common ancestors. Well, there's more to it in the world of life, and I'm not going to belabor it except for a few examples, which may be new to you, that I'm sure that many of you would know. Take the baboons, some species of baboon who live in troops of maybe 20 or 25 individuals, mostly females, with one dominant male, and then a few babies who are being breastfed. Well, if the male, the dominant male in the troop dies or is killed or is replaced by fighting or otherwise by another male baboon, the new male baboon, the first thing it does is to kill all the babies. This is exactly what you would expect from natural selection. Because if the baboon kills the babies, the females go into estrus. While they are feeding the babies, lactating, they don't go into estrus. But now they will go into estrus. The male mates with them, and now these females are carrying his genes. So any gene which will induce, or gene arrangement, will induce a male to do that, is going to multiply faster than a gene in a baboon that would not do that, because the one who kills the babies now has greater number of descents. That, by the way, the kind of behavior is very common in many kinds of animals, lions and others. And then you have these things that I call here oddities, like praying mantis. You probably have heard this insect that has the 4 legs like this, looks like if it's in prey. And the story goes that after the male mates, the female eats the male. Well, the part is true, but it's not the whole truth, because the female tries to eat the head of the male before they mate, because under those circumstances, the insemination of the female is more successful. The nerve centers in the head of the male that control the sexual behavior are not under control. The female takes control and gets better inseminated. These insects typically mate only once in their life. The best they can do for their genes, the male, the best thing they can do for his genes is to be eaten by the female, so that it's very healthy, produces more babies, healthier babies. They are his genes, and he's not going to mate again. So it's something that you would expect to happen. Well, variations of this behavior exist in hundreds of species, of insects, spiders, some crabs and the like, with all sorts of variations. Some eat the male before, some during, and some after mating. It's a strange kind of behavior to attribute to an intelligent designer. And then parasitism, where the only way in which these organisms can reproduce and live is by killing their hosts. So it seems almost like a case of sadism. Who would design organisms that can only live by killing other organisms, which has been several of these cases, but in the case of parasitism is the only way to do it. So this is my final set of statements that I will present with some trepidation, because it implies all of this. And what the last statement refers to, 20% of all human pregnancies end on spontaneous abortion during the first 2 months of pregnancy. That's because the human reproductive system is a mess. 20% of the pregnancies, 20% of the babies that get formed, the fetuses don't have a chance to survive, they die spontaneously. We may call it miscarriage, but actually the abortion word was introduced in the English language to refer to this mortality of babies during the early stages of pregnancy. Be that as it may, there are 100 million births in the world per year. So because of this very defectively designed human reproductive system, there are 20 million abortions per year in the world. I think that rather than blaming God, it's much more reasonable to account for that as a result of natural processes. After the Copernican revolution, people didn't have to say that when Vesuvius erupts and destroys completely the Pompeii and Herculanum, it was because God wants to kill the citizens of those cities because they were bad. Or, so these are the result of natural processes. There are tsunamis and earthquakes. The tsunami that killed 200,000 Indonesians 5 or 6 years ago, in the old times, was explained as the result of intentional action of supreme being. With the Copernican revolution, we say that's not so. It's a result of natural processes. And I think what Darwin did was the same thing, extending the reasoning to the world of life. We don't need to attribute the things that happen in the world of life, all these kinds of events, to the intentional design of a designer, but rather as the result of a natural processes. One final word, and I don't want to enter into the subject, the theological subject in any way, but sometimes people say, well, if God is the author of the world, he should be still responsible. Well, if he's the result of natural processes, there are some very important differences. First, there is no perversion or cruelty or anything, because when a baboon male kills all the babies, he's not doing something which is evil in the moral sense, because the baboon is not a moral subject. So there is no morality there. If I walk outside my home, it's an ecological reserve where there are lots of coyotes, and if a coyote attacks me, I don't see that as a moral act. However, if a dog, a mugger, uses his dog to attack me, that is a moral act of the one who is directing the dog to bite me. So in my view of seeing these matters, by the fact that we have removed the intention, the explicit design of the creator from these events, I think we don't need to consider them any more moral events, and therefore the problem of evil, or this is a way of looking at a way out of the problem of evil that Hume, among others, was pointing out, as Philip Sloan was telling us. Well, thank you very much.
I want to thank you, Professor Ayala. We have some time for some questions, and he's willing to take them here, so I'll let you field some of your own questions.
Okay. Bob. Bob Riches from the University of Chicago.
Well, you said you didn't want to get into the theological sort of line of succession here about responsibility. But isn't it just slightly disingenuous to say that this solves the problem of evil? Because after all, God has arranged the laws, and with prevision could have arranged them somewhat differently.
Yes, I may have misspoken, or maybe you have heard more that I meant to say. I don't think that solves the problem of evil. It's a principle can be used to solve or to deal with the problem of evil. I don't know that it solves it. That's for theologians to go into greater depth. I don't think it needs to be disingenuous. I think the example of the rather trivial example of the coyote and the dog is valid.
I think you're right about that, certainly.
Yeah, so, what happens in the natural world is not evil in the moral sense. The earthquakes, they destroy, they kill 50,000 Chinese a year ago. That's not a moral act. It's just a natural act. And therefore doesn't need to be attributed to the creator of the world. The world, for people of faith who believe that God is the creator of the world happens as it happens because of the way it was created. So, but there is no evil there because
I think that this is indeed a conversation to pursue with some good Spanish wine, I think.
Oh, I think so. I think so. Let us see whether there are more questions along the lines, because I was going to go a little further. Maybe it's better to leave it at that now that you are willing to take wine instead.
Yes, please come to
I was not at the time familiar with the progression that you showed concerning the development of the eye.
Could you give your name too, please?
Oh, I'm sorry. Paul Fisco. I'm from Phoenix, Arizona.
Mm-hmm.
I wasn't familiar with that progression of things. Very interesting, of course, from mollusks to octopus, those types of things with the eye. But in the progression, there's a note. There's a section where the creature does not have this simple lens, and then it does appear. My understanding is that what I'd like to know more about is that lens that suddenly appears in one block. It's not there, and then it appears.
Yeah.
And your talk about intelligent design, I completely agree with what you're saying. But isn't that what intelligent design seems to look for? Is that those things that are inexplicably inserted into? So if that lens and its appearance, and if there's random lenses in the ocean that have been captured by as mitochondria might have been at some point. You see what I'm saying? There's
Yes.
that moment there.
It would have taken more than 1 hour to explain the evolution of the eye with great detail. There is nowhere anything that cannot be explained, as far as biologists understand it, that cannot be explained as a small step. I was just giving some highlights, and to see, they are all mollusks, by the way. It's a very diversified group of organisms, and with very different lifestyles. Well, all vertebrates, virtually all vertebrates have the camera eye that we have. There are variations of it, but basically all the same parts. Mollusks don't. And the most important part there is the retina and the nerves. And then all the other things keep accumulating and making the eye more precise, more accurate, being able to see not only direction of light, but movement, and then the configuration of objects. But could have given you many intermediates, and I'm not an expert on the matter, but the evolution of the eye has been studied in much more detail with finer steps in between.
Thank you.
Ken Miller from Brown University. Francisco, there's a catch-22 that has been thrown in my face many times in arguing about intelligent design, and I'd like to see how you handle it. You said that intelligent design was not science because, among other things, it's not testable. But wouldn't an advocate of intelligent design then be able to say, the very fact that you are arguing against the propositions of intelligent design and endeavoring to show that they are wrong proves that it is testable, and therefore it is science?
No. No. Very good point. I will answer you in the way I answered in writing, not with respect that he would read it to a comment of President Bush. Alchemy is not science. And I can give arguments for why alchemy is not science. Witchcraft is not medicine, and I can argue why it is not medicine. And astrology is not science. We have chemistry and astronomy and medicine. These other alternatives are not science, and can argue against them because they are presented as science. But no, I don't think that I can be persuaded. You cannot be persuaded either. They are science, but it's good that you said it. The pathetic thing from the educational point of view is that the media, the newspapers, dedicate considerably more space, collectively speaking, to the horoscope than to astronomy, So we have astrology. People are educated on astrology, but not in astronomy. We have a tremendous deficiency, as you all agree, I presume, in scientific education, and partly because it's not very good in the schools, part because the media don't do very much trying to pursue the matter of providing scientific education to the population in general.
See, I think I had a question here and then went over here, but I think I can help you with that.
Gonzalo Muner from Lawrence Technological University. There seems to be one more argument on your side, and that is that when the intelligent design proponents argue, they normally come up with some kind of natural phenomena, and they say there can be no natural explanation for this. We can find no natural causes for this. Now, you are correct in saying that we can indeed find the causes, but if the reasoning were correct, then that would mean that we didn't find any natural causes, and therefore the explanations that will be given will be explanation based on unnatural causes, and therefore by definition not scientific. No. So what they do, that is what intelligent design does, cannot be scientific, because even if the reasoning were successful, they will have to appeal to non-natural causes.
Right. So it will not be scientific. Well, they are saying at the non-scientific level they are giving explanations, namely, creation by God or creation by the intelligent design. But yes, I agree with what you have said.
We had one question over here. Could you go to the microphone, please? Yeah.
Carl Helrick, Goshen College. I am a physicist, and I just listened to my colleague, I believe, from the University of Chicago, making a very good point about the theology involved here. And then eventually it dawned on me that I'm bothered by that. I don't think we can really do that. The point is that God could have built a better system that wouldn't have had all these problems in it and have this misery. And as a physicist, I do biophysics, I'm familiar with complex systems. I really couldn't quickly get around that. I think the only real alternative, and this is part of the question, isn't the real alternative to say either we have God that comes in and just manipulates everything, or we're stuck with you cannot really make it work.
Yeah, I have a slightly different take. We have a world, your world, but not particle physics, but more the astrophysics, where new planets form, new galaxies form. There's a very rich and interesting world. The continents move, which accounts for earthquakes and the like. God have created a world where nothing of that happened. One way of answering would be, who are we to tell God how God should do things? But the fact is that the world would be static at the level of astrophysics will not be a very interesting world. A world that God would have created where there was no evolution will not be very interesting. There have been 1 billion species or so in the history of life, and tremendous diversity and richness of imagination and motivation for seeing beauty and scientific developments there. Static world without evolution, with some organisms there. The static world that I saw yesterday at the Museum of Creation, I went there and they say, before the fall, all the animals were vegetarians, and in fact they were vegans, and there was nothing bad happening. It's all a consequence of the fall. Well, let me take the whole line of argument one step forward. God could have created robots rather than human beings, creatures that will be like us, but we don't have free will. So those robots will not commit crimes, and they will don't do other awful things that we do. But again, that world, I would claim, it's arguable, at least from a theological point of view, and that world would not be as interesting as a world in which we have human beings and we have evolution and we have astrophysics.
I think with that we're going to, I'm going to call at this point this section closed, but I wanted to announce that tonight Kenneth Miller is going to give a lecture at 8 o'clock as well, and it's going to be picking up on some of these issues, so maybe we can continue that discussion. What we have now, for those who have pre-registered, there's a dinner downstairs, and then the public lecture will be here in this auditorium at 8 o'clock. But I want to thank Professor Ayala
Thank you.
for getting us to the very good point.
Thank you.